today, we're going to talk about exponents. We're going to go back to exponents, but we're going to talk about negative exponents, at least in this section right here. They actually call them, they call it rational exponents. We're actually going to do both. So rational exponents. Have we talked about that word rational before? What's in that word rational? What math word is in that word? Ratio. Do you see that? Ratio. And basically, in ordinary language, what's a ratio? It's just a what? It's a fraction, yeah. Ratio is just a fraction, okay? So we're talking about fractional exponents. You're thinking, well, why didn't they just say fractional exponents? Okay, it made it a lot easier. Then I'd know what they're talking about. What they like to use the word rational, okay, in math. It's talking about fractions, right? So they're talking about exponents that are fractions, right? Not just to the second power, to the third power, to the fourth power. We're talking to the half power, or to the 1/3 power, or to the 2/3 power, okay? Does that any of that ring a bell? Do you remember doing any of that in Algebra 2? Now again, I'm not assuming that you know it and just say, okay, you should know it, here's the problems, do them. So I am going to teach it from scratch, but that's what we're talking about here. Let's first, before we get into the fractional exponents or the rational exponents, let's do a negative exponent first, because we're going to do a combination of fractions and negatives as far as exponents are concerned. So if I had... let's start off real basic. If I had x squared, what does that mean? Now I know that's not negative, I know it's not a fraction, but if I just said x squared, what is it? X times x. Alright, you with me on that? Now if I have something like this, if I have x to the negative second, it doesn't mean it's negative x times x. Right? This negative in the exponent does not mean that this answer is going to be a negative answer. It has nothing to do with that whatsoever. What it means is this. That's right.
Instead of x squared being in the numerator, put it in the denominator?
Exactly right. This is what we're going to do. Watch. Instead of having the negative, we don't really want to work with a negative exponent. A lot of times, I wouldn't say every time, but I'd say most times, a lot of times, we don't want to leave our answer with a negative exponent. Okay, most of the time, we want to change that negative exponent to a positive exponent. So I can't just make it to the positive second. It wouldn't be the same thing. But this is what it's telling us to do. This right here is saying this. All right, this is equal to this. X to the negative second is equal to 1 over x squared. That's what it's saying that it's equal to. All right. So what did that negative exponent do? It took this and did what to it? Flipped it, didn't it? It flipped it down to the bottom. So when you have a negative exponent, that's exactly what it does. Okay, it flips it either to the bottom, or if it was already on the bottom, it would flip it where? To the top. Okay, so that's what it's saying. It's basically saying it's the inverse. Okay, it's the inverse. So if it's on the bottom, I stick it to the top. But what do? I get rid of that negative exponent. By flipping it to the bottom, I get rid of the negative exponent, and it turns into a positive exponent. Does that make any sense? What if I had something like this? What if I had 1 over x to the negative third? What do I do with that? Yep, I take this, which is a negative exponent. I don't want it to be a negative exponent. I take it and I flip it to the top. If I flip it to the top, it becomes x to the positive third. I flip it and I change the sign. Everybody see that? So I flip it and I change the sign. I do two things. That's what a negative exponent tells us to do. Now watch. Once I've taken it from here and I flipped it up to the top, what's left on the bottom? It's just a 1, right? So technically it's over 1. Do I really need to write it over 1 though? Not really. But on this one though, watch. I took this, I flipped it to the bottom, I changed the sign so it goes away here, but what's left on the top? Is just nothing left on the top? No, it's a 1 because it was 1 times this, wasn't it, originally? You didn't always see it, but it's always there. All right, so a 1 is left on the top. Does that make sense? You could do that with, the base doesn't have to be an x. The base could be just a regular number. For instance, if I had this, 3 to the negative second. Again, what do? Well, I'm going to put it over 1 to begin with, just to make it look like a fraction. So what do? We take this whole thing, it's a negative exponent, what do we do with it? Flip it to the bottom. Okay? So what's it going to look like then? 3 to the positive second. Remember that? Okay, so we take it 3 to the positive second. We flip it, we change the sign. What's left on top? A 1, right? So we got rid of it here, put it on the bottom. Now we can simplify that, can't we? 1 over 9. So 3 to the negative second is the same as 1/9. We didn't make it a negative 1/9, did we? That negative has nothing to do with our problem being positive or negative. It's got nothing to do with it when it's up in the exponent. All right? What if we had this? Okay? Look at that one. Now this negative, this is not an exponent negative, is it? So that negative right there absolutely makes it, positive or negative. In this case, negative. Everybody writing this down? Okay. So what do we do? Well, I see that negative exponent. First thing I do, you don't have to circle. I'm just doing that as far as a teaching thing for you, just so you can see what's going on. But we take this and we flip it. It was on the bottom. It's a negative exponent, so I flip it to the top. Does that change this sign right here? Does that do anything to this? No, that negative still just kind of floats out in front. All right. So don't worry about this. This has no effect. This exponent has no effect on this negative right here. So if I flip it to the top, I get what? 5 to the positive third, right, to the third. And then I just work this out. All right, so it's negative. Keep the negative out in front, and then 5 cubed. What's 5 cubed? 5 times 5 is 25 times 5 is 125. All right, and that would be your answer right there. Does that make sense? Okay, so now we know a little bit about negative exponents. Now what we're going to do is get to what they really want to deal with in this lesson are the rational exponents, or the fractional exponents. Okay? Let's go green. Let's go to slate green. Okay, so let's do this. Let's just give a little definition here. So if I have x to the 1/2 power, let's say that. I'm just going to give you a definition. X to the 1/2 means the square root of x. That's what it means. Okay, so it's not x to the second power. It's not x times x. It's x to the 1/2, which is the square root of x. Let's do a few more. What if I had x to the 1/3 power? What do you think that means? This is the cube root of x. Exactly right. See, technically, we don't usually put a little 2 here, do we, for square root? Because we see square root so much that it's like, just put the little check mark thingy. The radical is what we call that little check mark thing. And we don't usually need to put a second right there. All right, but that's basic. That's what it means. You could if you wanted to, but we see it so much, it's just kind of a waste of time to put it there. But for a cube root, we do put the little 3. All right, so x to the 1/3 is the cube root of x. You kind of get the idea already, don't you? What if I went x to the 1/4? What would that be? The 4th root of x. All right, Norva, getting all this down? You writing this one down? Keep writing. That'll keep you awake. And then let's do one more just for fun, just so we kind of get a little pattern here. If I had the 5th root, it would be, I'm sorry, if x to the 1/5, it would be the 5th root of x. All right? Let's stick some numbers in and see what we're talking about. What if we had 9 to the 1/2 power? And I ask you what that's equal to. Well, 9 to the 1/2, anything to the 1/2 means the what? The square root. To the 1/2 means the square root of whatever that base is. So that's the same thing as the square root of 9, isn't it? So what is the square root of 9? It's just 3. Okay? You can put that into your calculator. We just happen to have a calculator right here. So watch. Let's put 9 to the 1/2. Turn it on. So how do we do that? 9 to the, see that's the exponent on this calculator, to the 1/2 power. I'll put it in parentheses. You could have put 0.5, but I'm just going to put it like this, okay? So 9 to the 1/2. Let's hope it works. Boom, there it is. Look at that. It's 3. You believe me? All right. Seems like nowadays kids just believe the calculator. They don't believe the teacher. But I was right. So 9 to the 1/2 means the square root of 9. That's exactly right. All right. Let's try another one. I won't do too many of these. What if we had, let's do that number we did before. What if I had 125 to the 1/3 power? 125 to the 1/3 power. What does that mean? Well, what it means is the cube root of 125. Now, I picked a number that came out nice and even, okay, and Jared got it. So what number times itself 3 times, okay, is going to equal 125? Well, that would be 5. All right, so 125 to the 1/3 power is the same thing as just a 5. Let's just see if it works here. So 125 to the 1/3 power, so 1 divided by 3. All right, isn't that what that is? It's saying? All right, and there you go. It's 5. It works, doesn't it? All right, so I'm not lying to you, am I? So there you go. That's what that stuff means. Yeah, oh yeah, you could get something that comes out to a decimal, absolutely. But I'm just showing you ones that come out nice and even. Yeah, that doesn't all come out this pretty, right? If I had like 72 to the 1/3 power, okay, there's no number that if I multiply it, or there's no whole number, I should say, if I multiply it by itself 3 times, then I'm going to get 72. All right. Now, I'm not going to make you figure out what that number is without a calculator, and I really doubt that I'll even make you even get a decimal number for something like this. Okay, there may be a couple times when you could, but let's just try it. 72 to the 1/3 power. To 1/3 power. Okay, and there's your decimal. Okay, so I mean, if you had something like that, sure, you can just stick in a calculator and get a number. Okay, alrighty. Let's do an example. Oh, you know what I should have done? I should have looked at my examples actually before I went to the fractional exponents. Let's go back real quick. We got some time. Let's go back real quick to that negative exponent stuff, and then we'll hit the fractions again. What if we had this? What if we had a fraction to a negative exponent? Let me show you a little trick. You may want to write some notes down, okay? Just a little note to yourself on what to do here. Now you could, don't write this part down right now, but you could do this. You could have put this over 1, take this whole entire thing, flip it to the bottom, then what would you get? You get 1 over 2/5 to the what? To the positive 3rd power, wouldn't you? Now watch, let's keep going with this. You don't have to write this part down because this sometimes gets a little too confusing. All right, and so now we're going to take this fraction, we're going to take it to the 3rd power. So let's take this 2/5 and we'll cube it. So 2 cubed is 8, 5 cubed, we've already done that, is 125. Now look, I'm showing you the long way. I don't even want you to write this down, okay? But I'm showing you that you get the same answer both ways. I'll show you a little shortcut in a second. So it's 1 divided by this, and we just talked about division. So what's 1 divided by? It's the same as 1 times the what? The reciprocal, okay? Multiplied by the reciprocal. So it's 1 times the reciprocal of this, which is 125 over 8. You don't need the 1 there, so I'm just going to leave it 125 over 8. That's kind of a pain, isn't it, to go through all that mess? Let me show you a little shortcut on this. Yeah, absolutely. And we'll just see. I just wanted to go this route because I wanted you to see that you're going to get the same answer both ways. But this is a nice way to do it. Watch. I'm going to rewrite the problem over again. So it's 2/5 to the negative 1/3. Now look what we got. We got 125 over 8 for our answer. So look at these numbers right here and look at this exponent. How in the world do you think I could take this and go almost directly to this? Okay, you could cube them both and flip them. I'm actually going to go the other way, but you could do that. You're absolutely right. Okay, you're not wrong in that. But what I'm going to do is I'm going to flip the fraction first. So watch what happens. I'm going to flip the fraction. Okay. Now, if I flip it, remember I did this? I flipped it down to the bottom. What did I do? I changed it to a positive exponent. But I'm just going to flip it within this fraction right here. I'm just going to take the 2 over 5 and flip it right now, 5 over 2. So instead of to the negative third, what's it going to be? To the positive third. You see that? And now it's really easy. Now I don't have to worry about any negative exponents. What can I do? Just cube everything in there. So that's 125 over 8. Isn't that a much better way than going through all this mess right here? Absolutely. All right? So if you have a fraction to a negative exponent, what do? Flip the fraction, and then you've got a positive exponent. And then you just apply the exponent to it. We good with that? Yeah, that's pretty easy. I should have done that before I did that fraction stuff. But we're going to do a combination of these, all right? We'll do quite a few little combinations here. So let's see where I want to go with this now. Okay, let's do this. What if I had 8 to the 2/3 power? Look at that. Now it's not just to the 1/3. It's not just the cube root of 8, is it? Everybody see that? It's not just a cube root. It's to the 2/3 power, not to the 1/3. If it was just 8 to the 1/3, that would be easy because I would say, oh, to the 1/3, that means the cube root of 8. What is the cube root of 8? What number times itself 3 times? It's 2, isn't it? Okay? So if it was just 8 to the 1/3, it wouldn't be that big of a deal. But it's not 8 to the 1/3. What is it? It's 8 to the 2/3. But what I'm going to do, I'm going to show you a little trick here. Do you remember that rule when you had like, remember this thing right here? If I have an exponent taken to another power, what do I do with those powers? I don't add them, I multiply. When I have an exponent to another power, I multiply them together. Remember that rule? Okay, that's just, I'm just trying to plant that in your head a little bit so you're thinking about this. Now watch this. What I'm going to do is I'm actually going to take this to the 1/3. But this and this aren't equal to each other, are they? Alright, so how in the world could I get this fraction to become 2/3 instead of 1/3? Well, I could take it to the what? Second power. Do you see that? Now look, I got an exponent to another power, right? What's the rule? Multiply the exponents. What's 1/3 times 2? It's 2/3, isn't it? So would you agree that this is the same exact thing as that? It's just written a little bit differently. Now why did I write it like that? Because I know how to take 8 to the 1/3 power, don't I? Now they've rigged these problems. Okay, I rigged it. I came up with this myself. Okay, aren't you proud of me? So I've rigged this thing so it comes out nice and even. All right. So I made it. So look, I took it 8 to the 1/3 first, and then I squared it. All right. So let's do that. What's 8 to the 1/3? It's 2. But I got to square it, and so what's 2 squared? It's 4, and then there we go. It's kind of like factoring. It's kind of splitting it up, right? It's splitting it up. And how do I know how to split it up? I could have done this. Watch. I could have gone 8 to the second to the 1/3, but I wouldn't do it this way. Don't even write this down, okay? Just watch it. I could have written 8 squared to the 1/3. Isn't that the same thing as 8 to the 2/3? But then look what I got to do. I got to go 8 squared is what? 64, and then I got to take 64 to the 1/3, and then I got to think of what the cube root of 64 is, and it's actually 4. So it still works, but you're going to get a lot bigger numbers doing it this way. So what do? I take 8 to the 1 over the denominator. Do you see that? So whatever the denominator is, and almost every single one of these problems, they've rigged them so it does come out nice and even, and then you can take that root of it. Okay, Norval, come on now. Norval, please. Don't do that. You know what I'm saying. Your eyes are closed. Your head's against the wall. Okay, don't give me this like, what's up? Okay, yeah, but you're not. Head up. Sit up straight. So we want to take it to the 1/3 power and then take that squared. That's a lot easier. So let's do one that's a little more complicated than this. Let me find a good one. All right, here's a good one. What if I take 32 to the 7/5? I didn't make this one up, but all right. Look at this. What in the world? I don't know how to take it to this. I'm not going to put it into a calculator, okay? I don't want you to put it into a calculator. I want to see your work. I want to see how you got this answer. But it's rigged again. So I'm going to take 32 to what power first? What did I do over here? I took that denominator, didn't I? I put 1 over the denominator. So what am I going to take this to? 1 over 5. And then I can take it to the what power? To the 7th power. Isn't that the same thing? 1/5 times 7 is 7/5. So 32 to the 1/5. Right? I already heard it once, but what's the 5th root of 32? What number times itself 5 times is 32? Well, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So it would be 2, wouldn't it? So it's 2 to the what? 7th. Right? And you can figure out what 2 to the 7th is. I think it's just 128. Because 2 to the 5th, we just said, is 32, right? Times another 2 is 64, times another 2 is 128. All right? And there you go. That's your answer. Now, let's try a combination of everything that we've learned today. You ready for that? So let's do it. So it's 16 to the negative 3/4 power. Let's figure out what that's equal to. Well, first of all, I don't like that negative exponent. So that's first thing I'm going to do is I'm going to get rid of that negative exponent, right? So I'm going to take that whole thing, flip it to the bottom. Let's see what we get. So there's a 1 on the top now once I get rid of this. And now it's 16 to the positive 3/4. That's the first thing I do. Everybody see that? So get rid of the negative exponent right off the bat. Now let's see what we can do with this. And now it's basically just like what we did in that last example. I'm not going to take 16 to the third. I'm going to take 16 to the what?
Fourth,
To the fourth, 1/4.
which is 2.
Right? And then I'm going to take that and I'm going to do what to it? According to this fraction right here. Take it to the third power, cube it, right? It's the same thing, isn't it? Isn't that 16 to the 3/4? But I broke it down so it's 16 to the 1/4 because I can figure out what 16 to the 1/4. Remember I said they rig this all the time? They've rigged it again, haven't they? Right? Because I can figure out what 16 to the 1/4 is. What number multiplied by itself 4 times is going to give you 16? Again, it's 2, isn't it? All right, so it's 1 over. So all this stuff right here is just a 2. But what am I doing to that 2? I'm cubing it. And so now we're ready to go. What's 1 over 2 cubed? 1 over 8. And then that's your answer. And it's a positive, isn't it? Some people look at this and say, Mr. Hamrick, how can this be positive? You had a negative right here. But does that negative in the exponent have anything to do with this problem being positive or negative? Nothing to do with it, okay? All it does is tells you to flip it, and then you change that sign. So I have no negatives in here at all, do I? And there it is. That's basically what you're going to do tonight. You okay with that? Yeah, it's pretty easy, isn't it? Do you remember doing any of this in Algebra 2?
Yeah.
Did you? Okay, good. So the worksheet is labeled 1-6A. I think I got like 3, maybe even 4 different worksheets on 1-6. All right, so this is part A. I want you to do them all this time, okay? You're going to do every one of them. All right.